In problem 35, we're asked to solve this inequality and then write our answer in set builder notation and interval notation. So let's do that. Now I could do stuff like add x to both sides and add 2 to both sides to get x by itself, but I'd like to get rid of this fraction by multiplying both sides of this inequality by positive 2. When I multiply both sides by positive 2, since 2 is a positive number, I don't have to switch the inequality sign around. So this 2 distributes. 2 times 1/2 is 1, so we have 1x. And then the 2 distributes to the minus 2, we have minus 4. Over here we have 2 minus 2x. So all that's done is make every term twice as big, but now I don't have to worry any longer about fractions. So I'm going to add 2x's to both sides. That'll bring the x's to the left-hand side. I'm going to add 4 to both sides. That'll bring the numbers to the right-hand side. So here I get 3x plus nothing, and over here I get 6 plus nothing. I'm going to divide both sides by a positive 3, and when I do that, the inequality stays the same. If I divided both sides by negative 3, this inequality would have to turn around. So we have this. In set builder notation, this is the set of all x's such that x is less than or equal to 2. In interval notation, it's everything smaller than 2 and equal to 2. So 2 is the biggest number. We put the biggest number on the right. We use a bracket to show that x could actually equal 2. And then the idea is everything smaller than that works. So we want to go left forever. Left forever. And when we use that infinity or forever symbol, by standard practice, it's always a parenthesis. So this would be the interval notation. It does not ask us in this problem to graph the solution, but if we were asked to graph the solution, 2 seems to be the critical number. And 2 is a possibility, so we could fill it in, and everything smaller than 2 is filled in. This is one picture of all the numbers 2 and smaller. This is another way of describing all the numbers 2 and smaller, and this is another way of describing all the numbers smaller than or equal to 2. One other way to graph this, very similar, still haven't really gotten used to writing on this thing, would be instead of the circle, well, sorry about that, but instead of the circle, we could use a bracket, meaning that it could be equal to 2 as well. And so we have this kind of picture getting us ready for interval notation. Now I wanted to do one more thing with this. So I'd like to take this problem now and do it in a different way, kind of like the problems 25 through 28. So we're going to go back to the 1/2 x minus 2 is less than or equal to 1 minus x. And our plan is going to be here to make this be a function. I'll call it f. And it's the function 1/2 x minus 2. And make this side be a function. Call it g to keep things simple. And it's 1 minus x, and so this inequality becomes f of x is less than or equal to g of x. And now we're going to graph this, but in graphing it, I would like to use Desmos, so let's try that. So you can see what I've done in Desmos. I've graphed the two functions f of x and g of x that we talked about earlier, and now I have a picture of them. And our inequality that we're trying to solve is when is f of x less than or equal to g of x? Well, when are points on the red graph smaller or lower than points on the blue graph, because you'll recall when we graph functions on an xy axis, the y is the output. The y is what the function is generating, so the height is the output. So down in here, on the lower left-hand side of the red graph, we can see that the points here for like x equals 0 and x equals -1 and x equals -2, these points are lower than the ones on the blue graph where x equals 0, x equals -1, and x equals -2. So the red graph is lower than the blue graph, which means it has smaller values, which means it's less than, all the way up to 2 where they're equal. And then on the other side of 2 it switches. So what is the answer to the question, when is this 1/2 x minus 2 function smaller than the 1 minus x function? It's smaller everywhere to the left of x equals 2. Where is it equal? At x equals 2. So where is it less than or equal to? It's less than or equal to at 2 and everything less than 2. If we go back to our setup here, we can see that the answer to the question, the answer that we already knew, was that when x is 2 or less, this side is less than or equal to this side. So this graphing provides extra understanding. I hope that you use Desmos to do this graphing. It will help you understand what's happening with these functions.